So we're doing analytical geometry, and our first question is going to be the one that comes from Akhata Midaka. So Midaka, this one is yours. Let's see what you wanted assistance with. Right. So like I said, we're doing analytical geometry, and I want to just put it out there that in analytical geometry, before we even start answering this question, you guys need to know basics, very, very simple things that we taught you from grade 10. In fact, from as way back as grade 9, the concept of working out distance between 2 points. You've got to know how to work out the distance between 2 points using the distance formula. So the distance formula, which is basically given by d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. This is the distance formula, which is what we use to work out the distance between 2 points. The other part that is important that I want you to know is how to work out the coordinates of the midpoint, right? The midpoint is basically a point that lies between 2 points on the Cartesian plane. If I've got a point here, which I might call point A, and I've got another point here, which I might call point B, and I join them, right, with a line segment, somewhere in the middle there, there's a point which we call the midpoint, right? If you want to work out the coordinates of that midpoint, the formula you're going to use is that the x coordinate of the midpoint is always given by the sum of the x's divided by 2. It's like working out the average of the x coordinate. And the y coordinate of the midpoint is given by y1 plus y2 divided by 2. You sum up the x's, divide them by 2. You sum up the y's, divide them by 2. You'll work out what we call the coordinate of the midpoint, because this will come here and that will just come there. I like writing it the way I did first time because it actually helps me to work out any unknown if I know the coordinates of the midpoint. Right. The other thing that is important, that is fundamental in analytical geometry, is the whole concept of figuring out what we call the gradient, right? The gradient can be worked out in 4 different ways, if not 5 different ways of working out the gradient. So the gradient is one of the most special things in analytical geometry, because if you've got 2 points, right? If I give you 2 distinct points and I ask you to work out the gradient, you're going to use the gradient, which is what we call the average gradient, as y2 minus y1 over x2 minus x1. Change in y over change in x, or rise over run. If you don't have 2 points, right, you might have 2 parallel straight lines, right? What is special about parallel straight lines? Well, we've got a line that might be parallel to another line. If those lines are parallel, then we know that the gradient of the first line would always be the same as the gradient of the second line. These are the important basics that I need to remind you, because it is exactly what we are going to be running through as we try to solve all the problems that you guys send to us. And if you don't have parallel lines, you might have what we call perpendicular lines. If you've got 2 perpendicular lines, what do we know about perpendicular lines? Well, perpendicular lines is lines that meet each other at 90 degrees, right? So if you've got 2 lines that are perpendicular to each other, we know the product of the gradients will always give you an answer of -1. Right, so the other thing that is very crucial, that is very important, is what we call collinear points, right? Collinear. When you say things are core, it means they are doing something together, right? So collinear points are points that lie on the same straight line. If you go back to the example that I gave you about point A, point B, right there at the top left corner, it means that point A and point B are lying on the same straight line, so they're collinear. And even the midpoint is also lying on the same line. So I can actually claim that that point A, M, and B are collinear if they lie on the same straight line. Now that also helps us to work out the whole issue with the gradients, because if I've got 3 points that are collinear, which we can call point A, B, and C, it will mean that the gradient of AB will be equal to the gradient of BC, and it will be equal to the gradient of AC. The gradient of collinear points, right, will always give you the same solution. The last thing that I want to highlight here is the whole story of what we call the angle of inclination, right? The angle of inclination is the angle that you actually measure between a straight line and the positive x-axis. What am I talking about? Well, imagine a Cartesian plane. I might have a Cartesian plane like this one, right? And you will agree with me that that's the x-axis and that one is the y-axis. If you've got that and I have a straight line that is cutting through on that Cartesian plane, there's a nice angle that gets formed from the positive x-axis to that straight line. That angle there, which we might refer to as theta, is what we call the angle of inclination. How do you work out the value of that angle? Well, you can actually just do the following. The angle of inclination has a relationship with the gradient of the straight line, and that relationship is that the gradient of the line will always be the tangent of that angle of inclination. Very powerful basics that are necessary for us to be able to answer any questions in analytical geometry. This is actually your bread and butter, guys. This is where you collect marks, because we know there's going to be a lot of fighting that goes on when you do trig and geometry. So you can't go beyond this section without collecting maximum marks. Because you're watching Tenfold live today, we're going to make sure that you understand what is going on. The last thing that I might want to highlight is the whole story of finding the equations of a line. If you want to find the equation of a line, we know we're going to use y is mx plus c, or you're going to use y minus y1 is m into x minus x1. And all these things are available in our formula sheet or the information sheet that assist you to be able to figure out any of the things that you could be worried about. So what do you need in order to find the equation of a straight line? You will always need two things. These are the ingredients. The ingredients you need in order to find the equation of a straight line. You will need what we call a gradient of that line. And after finding the gradient, you also need a random point. When you've got a gradient and a random point, you can then find the equation of a straight line. So this is where we have actually managed to get you guys as far as grade 11's work is concerned. So what is new? What is new in grade 12? What is new in grade 12 is finding the equation, right? Finding the equation of a circle, right? Finding the equation of a circle. As a matter of fact, some people call this part circle geometry. I don't like doing that because it confuses the whole concept with what we do in Euclidean geometry. There's a lot of circles you worry about in Euclidean geometry, even in analytical geometry, we also have circles that you worry about. So this is what is new. If you are a grade 11 learner or a grade 10 learner, this is the only thing that is new. This is where grade 12s are actually supposed to focus more, because that's specifically for them. What do we know? Well, we know that you can have a circle that might have a center at the origin, or a circle that might have a center anywhere on the Cartesian plane. Let's try to show you. For example, I might have a circle here, and you find that my Cartesian plane is drawn such that the center of the circle is the origin. By the way, the origin is where the x-axis and the y-axis meet each other, the point 0, 0. So if this is the circle that you're dealing with, the equation of that circle will just be x squared plus y squared is equal to r squared. If your circle happens to have a center somewhere else, anywhere on the Cartesian plane, like this one here, and maybe your Cartesian plane looks something like that, you will agree with me that the coordinates of the center are not going to be at the origin. They'll be somewhere there, somewhere there. So we normally denote those as A and B, and we obviously have the radius of the circle, which is given by r. The equation of this one will be x minus a squared plus y minus b squared is equal to r squared. And this is just a nice summary that helps you to understand what the story is here as far as your analytical geometry is concerned, and the things that you're going to have fun on as we go through in this particular show. Right, everything that you've seen before is pretty much the same. The only thing that is new is the whole story about circles. So the distance between 2 points, the midpoint is always that you're looking at right now. We've got the gradient, which can be found in 5 different ways, if not more. 2 points, changing y over changing x. If you've got parallel lines, you've got the same gradient. If you've got perpendicular lines, the product of their gradient is -1. And collinear lines that lie on the same straight line will also help you to find the gradient. And in addition, if you are given something we call the angle of inclination, you can use that to figure out the gradient of that particular line. Of course, you also need to know how to find the equation of a straight line. This is not news. It's something we've done for many, many years. And the last thing is how to find the equation of a circle. Of course, there's applications of analytical geometry, which is where you guys normally struggle, right? The whole concept of knowing the properties of polynomials is going to play a big, big role when you're trying to start working with these questions. So I'm going to just say this to you. Applications. Mathematics is applicable, guys. It doesn't end on analytical geometry. So applications of analytical goes hand in hand, right? With other concepts, with other topics. Let me just call them topics, where the other topics include your trigonometry, your Euclidean geometry. You're going to see those questions, because I see some of the questions you send to me require us to engage our Euclidean geometry, to engage our trigonometry, and so on and so on. And also the whole concept of measurements, properties of polynomials, all those kind of things are very necessary, and you guys need to know how to work with them. You could be dealing with an analytical geometry question, for example, and the first question says, prove that this is a square. So if you don't know what is a square, you will not be able to survive answering that question, even though you know how to work out the distance, the midpoint, and the gradient, which is what is analytical geometry. Distance, midpoint, gradient, equation of a straight line equation of a circle. That's where analytical ends. If you know how to do that, you should be able to answer any question, because anything beyond that is no longer the problem of analytical geometry. It is now the whole issue of do you know how to work out an angle if you've got two sides in the right angle triangle? Do you know properties of tangents in relation to circles? Do you know properties of other polynomials, like what makes a rectangle what it is, what makes a parallelogram what it is? So those kinds of basics that you learn from grade 10 are also going to play a big role in this. So please make sure you also revise those basics. On our app, we've got those kinds of guidelines and tips that we guide you on. So go and download that app. It's called Tenfold Education. It's available on your app store. Right. So let's get on with today's questions that you guys sent us and show you how do you actually apply all these concepts in answering the question. So the first question, like I said, is from Midaka Ahata. So it says the following. It says to us here, in the diagram below, which is not drawn to scale, of course, obviously, there's a point A with coordinates minus 8 and 6. There's a point B, there's a point C and D, which are vertices of a trapezium, right? A trapezium. What is a trapezium? If you don't know what is a trapezium already, there's going to be a problem, right? So please go and revise those basics you learned from grade 10 that talk about polynomials, particularly your quads, right? Your quadrilaterals, square, rectangle, parallelogram, trapezium, and a kite. Those things are very important. Please go and revise them as well. Right, so there's apparently a trap on this question, which is drawn here. So let's try and put that here so that you guys can see what I'm talking about as I try and explain the story here, right? Let's have the Cartesian plane first. There's my Cartesian plane, which I'm going to draw like that. Okay, cool. Now there's a point apparently somewhere. Somewhere here, there's a point. And there's another point somewhere there. There's another point somewhere at the top, somewhere there. And there's another one somewhere there, right? So this is actually what we are dealing with right now. So I'm going to join those as part of my trapezium so that you guys can see what this trapezium is. It's actually from here to there. We've got another one from here to there, and we've got another one from here to there. It's not really drawn to scale. It might not be as accurate as I would love it to be, and we've got that. So this is my trapezium, and we are told that there's point A on it, which I'm going to now put here. There's point A. The coordinates of this point A are simply -8 as well as -6. And the coordinates of point B are actually 8 as well as 10. So we've got those. Those are the coordinates. Of course, the y coordinate has to be positive, Schofield. Fix it is -8 and 6. And the other one is point B, which is 8 and 10. Right. We also have point C, right? Point C is this one here. The coordinates of point C are not given. We don't know what the coordinates of point C are, right? And we also know there's a point D right there at the bottom on top of the x-axis. It's given by the coordinates -2 and 0. We did expect the y-coordinate to be 0, of course. And then the origin is there where point O is currently located. Now there's another line here, which I'm going to use a different color for the purpose of simplifying the whole story for you. There's a line that goes through BD, right? Which apparently passes through another point, which is given by T. There's a point T that lies there, and there are no coordinates given of point T. But we are told that this T is the midpoint of that line BD, of the line segment BD. Beautiful stuff, right? Okay, the last thing that is also indicated on this drawing is apparently another line here. Let's just see if we can be able to put that down without repeating colors. Okay, let's put it like that. Let's put it all the way up to point M. There's another straight line that goes down that is apparently perpendicular. It is perpendicular to the x-axis, and it meets the x-axis at point M, right? This is my x-axis. It's cutting the trapezium at point F, and the coordinates of point F are given as 8 and 3 as well as 1/3. Beautiful stuff, right? Okay, cool. So yeah, that's what is going on right now. We see that BC is apparently parallel to AD. Okay, cool. So I actually drew my sketch a bit off there. We want that BC to be equal to be parallel to AD. That's how this trapezium is drawn. Okay, let's fix that so that it's going to make a whole lot of sense for all of us, right? All right. So I need to actually reverse my point C because it currently doesn't look like they're parallel, and they need to be parallel with each other right there, guys. So we need that to be parallel to the other one, which means my lines have to be from here and drawn like that so that it's actually parallel to what you are looking at right now. Okay, cool. So now we want to actually find a couple of things as far as this question is concerned. without complicating things. Let me use a straight line here. I hope this is not going to cause problems. It's going to be like that, right? And it's going to be like that. So I just moved C closer there because we need C to be parallel to the other line. Otherwise, the whole drawing does not make sense. Beautiful stuff. And F needs to move away from where it is right now because it has to be where the lines actually intersect each other. So it must be there. That's where point F is, and the coordinates of point F are 8, as well as 3 and 1/3. Beautiful stuff, right? So what do we know? Well, we know that this line BC is apparently parallel to AD. They're parallel to each other. And that should tell you something if you are an analytical geometry learner, a grade 12 learner, a grade 11 learner, even a grade 10 learner. You need to know what that means as far as the graph is concerned. So point T is the midpoint of the line BD. From B, the straight line drawn parallel to the y-axis cuts DC at F and the x-axis at M. So that line there, BFM, that line BFM is perpendicular to the x-axis and it's obviously parallel to the y-axis. Right, now we are ready to start answering questions. Okay, cool. So the first question here says we need to calculate the gradient of the line AD. So very important for you to look at the line AD. It is far left. It has got the point A and the point D on it. This is a straightforward calculation question of an analytical geometry application where we are looking for the gradient of AD. Remember, we use M to denote gradient, small letter m, and we know that this is going to be y2 minus y1 over x2 minus x1. Now, it's good practice for you to use the variables, the labels of this as subscripts, which means instead of saying y2 minus y1, I can say the y value at D minus the y value at A divided by the x value at D minus the x value at A. This assists us to avoid confusing the 2's and the 1's because the way you guys do things, sometimes you make mistakes. For example, if I'm looking for y2 minus y1 over x2 minus x1, some of you swap these things around. So if you want a particular point to be your starting point when you are doing your subtraction, you need to also keep it the same when you're doing the subtraction for the axis. You can't say y here minus y there, and then you say x here minus x there. That will be wrong. If you do this minus that, even your axis must be this one minus that one. The direction needs to be the same, right? So the usage of the subscripts that I'm using currently helps a lot because it's going to help us not to confuse these things. So what is the y value at point D? The y value at point D is 0. So I'm going to have 0, right, minus. What is the y value at point A? It is simply 6. Everything divided by the x value at D is -2 minus the x value at A is -8. Beautiful stuff right there. So if you work this thing out, you're simply going to have -6 divided by +6 because that's going to be 2 plus 8 to a -8 multiplied by the negative outside of that bracket, multiply with each other. And the gradient that I'm getting here is just simply going to be -1. Does this make sense? Well, a negative gradient means your straight line is a decreasing line when you look at it from left to right. And if you look at the line AD, it is decreasing when you're looking at it from left to right. It's going down. It's going down that way when you're looking at it from left to right. So I am indeed expecting to get a negative gradient. So we're happy with the fact that we got an answer of -1. Right. Moving along to 3.2, it says we need to determine the equation of BC in the form y is mx plus c. So the examiner is now interested in the equation of the line BC. You look at your diagram, you allocate where BC is. There's BC right there, top right, and we are looking for the equation of this. Now, in order to find the equation of any straight line, you're going to need two things. In order to find the equation of any line, you need to know what is the gradient of that line, and you also need to know what is the point that the line is passing through, any point that the line is passing through. These are the ingredients that are necessary for you to find the equation of the line. So fortunately, we do have point B. So I'm going to use point B to find the equation of BC, and the coordinates are simply 8 and 10. But the gradient I don't have. I don't have the gradient of BC. However, we were told that the line BC is parallel to the line AD. So I'm going to argue it and say the gradient of BC that we are looking for, that gradient that we're looking for is going to be the same as the gradient we just calculated because those lines are parallel to each other. So the gradient of BC is going to be the same as the gradient of AD. It's also going to be -1. Why? It is because those lines are parallel to each other. Right. Then I can then continue and use my y is mx plus c to find the equation of that straight line. For y and x, I'm obviously going to sub for y, and for x, I'm going to sub the coordinates that we're looking at here. This x is going to come here as the x value, and the y value, I'm going to just substitute that 10 there where I see y. So I'm simply going to end up with 10 equals the gradient, which is -1 times my x, which is 8 plus c. This is minus 8. You add 8 on both sides of the equation, you're going to get 18 as c. Therefore, the equation we are looking for is y equals to minus 1x plus 18. And that will be the solution for the equation of that line of BC that they're asking us about. Right. Okay, cool. So the follow-up question says to us here, now we need to prove that BD is perpendicular to AD. That's what they're saying here. They say we need to prove. That's what the third question says. It says prove, right? This is number 3. Prove that the line BD is perpendicular to the line AD. Right. So analysis. What do we know about perpendicular lines? Well, when anybody talks about perpendicular lines, we know that the gradients, when you multiply the gradients of those lines, you must get an answer of -1. That's what the whole story of perpendicular means. This thing tells you that the gradient of the first line multiplied by the gradient of the second line must give us an answer of -1. Right. So let's go back and check what we know so far. Do we know the gradient of BD? We don't know the gradient of BD. We need to figure out what that is, right? We don't know the gradient of BD is missing. But we know the gradient of the second line, which is AD. So if I just continue here below so that you guys can be able to follow what I'm doing. Do we know the gradient of BD? No, I don't know what this is. Do I know the gradient of AD? Yes. We did find this as -1. So I'm looking for the gradient of BD and try to check if this does give me a product of -1. If it does, then that is conclusive enough that those lines are perpendicular to each other. So let's go and locate BD on the diagram. BD. Where is BD on our sketch? Well, BD is a diagonal of our trapezium. So we're looking for the gradient of that BD. Where am I going to work it out? Well, let me just steal some space here and work out the gradient of BD and this small space that we have here. So the gradient of BD is also going to be y at D minus y at B divided by x at D minus x at B. So, well, if you look at this, Midaka, and you try to do the substitution there, your y value at D is 0 minus the y value at B. You'll notice I use parentheses to avoid confusing myself here. The y value at B is 10 divided by the x value at D is -2 minus the x value right there at the top is just simply going to be 8. Right, and then if you simplify all this, you end up with a solution of -10 over -10, which gives you an answer of exactly +1. Right, so I'm going to take that now and replace it where it says gradient of BD, and that's actually where my +1 is. And when you multiply these two, you indeed end up with an answer of -1, which does indeed conclude that because we're getting a product of -1, we can then conclude to the examiner and say, well, this is conclusive enough that we can then say, therefore, BD multiplied by AD, BD and AD are basically perpendicular to each other. So let's use the correct mathematical symbol to argue what we're currently looking at. Beautiful stuff indeed, right? Okay, so the next one says we need to calculate the size of BDM. Calculate the size of angle BDM. Angle BDM. Where is angle BDM on the drawing? So angle BDM, I'm going to indicate it in green. Please focus from point B at the top. You need to go to point D on the x-axis, and then you need to go to M. So the angle that I'm creating is this angle here. That is the angle that the examiner is interested in. This is the angle that the examiner wants me to figure out. So I'm going to call it theta for the sake of simplifying what is going on here. Remember, if you're going to introduce things, you need to put them on your diagram, because when the markers are marking your work, they're going to keep checking what you have on the diagram. So you can't talk about theta if there's no theta on your sketch, because we're going to mark you wrong. We don't know what you're talking about. You need to show us what you're talking about. So I'm introducing that angle BDM as theta, and I'm going to then use the concept of the angle of inclination. Remember what we said? We said the angle of inclination is the angle between the x-axis, the positive x-axis, and the line of interest. So you want me to work out that angle for you? Well, I'm going to actually do that for you by just going back and saying, what is the story that we know here? Well, you want me to work out the value of angle BDE for you. So I'm going to say to you, the tangent, right? The tan of that angle that you're looking for, which I just call theta, is the gradient of the line that makes that inclination. And that line that makes the inclination, if you go back, let's go back and look at it. That angle that you're looking at is the angle that is made by the x-axis and the blue line. Because the blue line is the line that you're working with, which means we are looking for the inclination of the blue line, which means we are interested in the gradient of BD. And we did find the gradient of BD as positive 1. So I'm going to say we're looking at the gradient of BD. So that makes the tangent of theta to be equal to positive 1. And theta is arctan of 1. And this gives you an answer of 45 degrees. You should know this because 45 degrees is a special angle. That means that the angle they're looking for, which is BDM, is just simply equal to 45 degrees. Right. Is there another way you could have worked out this without using the angle of inclination? Well, you could. You could. Let's go back and do some engineering on this question. Look at it very carefully, right? You will agree with me that point M, please focus on point M, right? I'm going to actually remove the equation of the line that I have here so that I have space in order to explain something beautiful to you. The analysis of analytical geometry does not only end on analytical geometry. If you look at this the triangle that is blue, the blue triangle, right? The blue triangle starts at point D. Let me use blue so that you can see from point D. It goes to point B, and then it comes back to point M, and it comes all the way back to point D. My drawing is very much skewed. It's not up to scale. We know that this is 19. At this point is M, at this point is D, and at this point is B, right? I'm just focusing on the blue triangle, right? Now, if you look at that, you'll agree with me that the x-coordinate of D is -2, and the x-coordinate of M is going to be the same as the x-coordinate of B because they lie on the same straight line that is parallel to the y-axis. So whatever the x value at B is going to be the same x value at M, which means the coordinate of M can be thought of as 8 as well as 0 because this is directly below point B. They will have the same x-coordinate. Now the distance you will travel to move from point D, distance, keep that in mind. I'm not saying the coordinates, the distance that I'm going to travel from point D all the way to point M will be 8 units from 0 to M and 2 more units from D to O, which in total is equal to 10 units. When you're considering distance, do not look at the negative values. M is 8 units from O and D is 2 units from O on the left. So the whole distance between D and M is 10 units. And that means in my criticism on this triangle that I have here, I can actually have this as 10 units. If I look at BM as well, from point B going up to point M to B, from M to B, the whole distance of traveling is also going to be the same as the y-coordinate of B because that y-coordinate of 10 tells you how high is point B from the x-axis. And it happens to also be 10 units. Now this is an isosceles triangle, and you guys should know in an isosceles triangle these angles need to be the same. So if those angles are the same and one of them happens to be 90, and we know that sum of angles of a triangle must give you 180, this must be 45 and this one must also be 45 degrees. So you could have used your Euclidean geometry knowledge to figure out that angle of 45 degrees without using the concept of analytical geometry, which is the whole story of angles of inclination. So you could have used this analysis to also figure out that indeed that angle has to be 45 degrees using sum of angles of a triangle and your knowledge of Euclidean geometry. Beautiful stuff, right? Okay, now the other question that we have here is actually a beautiful one that says we need to calculate the coordinates of point C. We must find the coordinates of point C if C is symmetrical about the line BM, right? So it is symmetrical about the line BM. Symmetry. What is the meaning of symmetry? When you say something is symmetrical, it means they are equidistant from that particular line, right? That point is actually the reflection of the other one by the line of symmetry, right? So apparently the line BM is the line of symmetry for point T and point C, right? And we are told that the line CT is parallel to the x-axis, right? So let's try and find the coordinates of C. That's what they want us to do here. Okay, cool. So the question reads as follows. It says, if it is given that TC is parallel to DM, right, and the points T and C are symmetrical about the line BM, find the coordinates of C. Okay, cool. So let's look at this. Okay, so we want to find the coordinates of C, right, which is this point right there. Okay, I did my argument here with this. Let me just remove it so that we have this space. I want you guys to keep looking at the diagram as I use it to answer the question, right? If you look at point T and point C, right, they look as follows. The line of symmetry is this line here, right, which is the line from B all the way to M, right? apparently this is the line of symmetry. And we are also told that that line TC is parallel to DM, which means it is parallel to the x-axis. It doesn't look that accurate in my drawing, but let me just say this. This is apparently parallel to the x-axis. What does that mean? That means the y value at point T will be the same as the y value at point C. So what I'm looking for here is the following story. I've got point T here, right? This is point T. And I've got point C somewhere there, which I'm going to put there. What we know so far is that if these lines are symmetric about that line, the movement from T to the line of symmetry will be the same or equal as the movement from the line of symmetry to point C. Keep that in mind, right? So what do we know now? We need to find, of course, the first coordinate of point T, which we were told that T is the midpoint of BD. So I'm going to use my analytical geometry to figure out what are the coordinates of T, right? Let's figure out the coordinates of T. Okay, cool. So I'm going to remove this so that you guys can see what is happening here, because I want you to keep looking at the diagram as I try to solve the problems. So we are looking for the midpoint, which is point T, the coordinate of T. So T is going to be given by the x value of B plus the x value of point D divided by 2, and the y value of B plus the y value of D divided by 2. It's the midpoint. We're using the concept of the midpoint to find the coordinate of point T. So T is going to be, what is the x value at B? The x value at B is 8, and the other one is -2. So we actually have 8 added with -2 divided by 2, and the y values are just simply going to be 10, because the y value at B is 10, and the y value at D is 0. So it's 10 and 0. So 10 added with 0 divided by 2. So the coordinates of T are simply 8 minus 2, which is 6 over 2, which gives you 3. And then this is 10 over 2, which gives you a value of 5. So those are the coordinates of point T, which I'm going to put here on my drawing. So this one is apparently 3, and this one is apparently 5. Right. So we've got those coordinates. Now, the important thing that I want you to know is if a line is parallel to the x-axis, it means that it has a gradient of 0. And if it has a gradient of 0, it means that all the y values on that line are going to be the same, because the equation of that line will be y equals to some constant, right? So all y values on any horizontal line that is parallel to the x-axis are the same. So which means I'm expecting the y coordinate of T to be the same as the y coordinate of C, because they lie on a straight line that is parallel to the x-axis. So let's go and put that down in our sketch. So what does that mean? That means that point C that you have there will have the same y coordinate. That point C will have the same y coordinate as point T, which means it's also going to be equal to 5. Now the x values, let's look at what is going on here. To move from T to travel to point where the blue line is, you're moving from where x is apparently 3, right? X is 3 here, to where x is equal to 8, because here x is 8 on the blue line. So when you move from where x is 3 to where x is 8, you are traveling a distance of 5 units. Now that means if I'm traveling 5 units from point T to the line of symmetry, I also need to travel 5 units from point C to the line of symmetry, right? Because they're equidistant, which means if you move from point T, you travel 5 units, you get to the yellow line, which is the line of symmetry. And now to move from there, if you travel 5 more units, it's just as good as adding 5 on top of 8, and that will leave you with an answer of exactly 30. And those will be the coordinates of C. Right, so it's a beautiful question indeed that shows you the analysis that you guys need to also engage beyond working out distance, midpoint, and gradient. It was a nice question that helps us to work out with parallel lines. Parallel lines have got equal gradients. Perpendicular lines give you a gradient of -1 when you multiply them. And if you're dealing with the equation of a straight line, you need a point and a gradient to find the equation, and then that is as far, okay, and the midpoint as well. We also did get an opportunity to calculate the midpoint, which was necessary for us to work out the coordinates of C. Beyond that, anything else was just pure analysis that is based on other concepts and logic.